Hello, I'm Sudarshan Naik. Really, I'm very happy to teach about physics and all the doubt clearing. Every classes, after classes, we clear the doubt. So someone asked me about the related while proving the value of a numerical value of gravitational constant, that is 6.67 into 10 to the power minus 11 Newton meter square per kg square. At that times there will be a confusion about taking units. What is the unit of universal gravitational constant of G, and what is the unit of centrifugal force while taking the laws of Kepler's law. While taking the Kepler's law, there will be the universal gravitational constant, and here is like this. Here is G. G is called universal gravitational constant. So 6.67 into 10 to the power minus 11 Newton meter square per kg square, and it is comes G. What is G? Force, capital G. This is m1 m2 upon r square. Therefore G equal to that is G like this, cross multiplication, okay, that is force G r square, capital G m1 m2, and this is f c r square upon m1 m2, that is G. This is the universal gravitational constant. Universal gravitational constant. Last class just I missed to written TA. So while physics is very important subject, while understanding, while learning, while studying, that time carefully learn. Okay, so you manage the right answer or right spelling. This is okay. So here universal gravitational constants like this, and it the SI unit. This is the all the SI unit. All the SI unit of left side. This is the left side. Left hand side. Left hand side. Here the SI unit. Force SI unit is Newton. Meter is the SI unit of distance. R is the distance. What is the R? The distance between two bodies, center to center, while it is present in the universe. That is present in the universe at like a height of any height, just in the space. Whenever the body is suspension in the space, the center to center distance is called R. This is R, and distance SI unit is meter. So R square, that is the meter square, and this is the meter kg into kg, meter mass into mass, that is mass square. This is kg is the unit of mass. So here is mass into mass, that is mass square, and this is kg into kg, that is kg square. That is the kg square G, and this is this is the universal Fg, according to Fg universal gravitational force in the Kepler's law, or any. Here is earth is like there. Here is earth. Okay, here is earth. Here is earth, and body is here like m1. This is m2. So here is the distance r. This is the center to center body, and force is acting line joining between them, and this is called the universal force because the body is at the height, any height, just suspension at the height like h height, and fall down toward the center to our earth. So here there is the universal gravitational force is acting the line joining between them, the body to body m1 and body m2. The center to center distance is called the r, and here is r distance. The universe, here is the universe. So here is the universe, then it is F, and it is here the universal G is equal to Newton meter square per kg square, equation 1. In the same things, while it is proving, why we call the capital G is the universal gravitational constant. While proving this one, the time there is the Kepler's law is implemented. Whenever they are implementing the Kepler's law, at the times the centripetal force is applied. Right? While applying the centripetal force, there is the centripetal acceleration, acceleration and angular acceleration. So here is look like this one. Universe, Kepler's law. What is the Kepler's law? Two bodies related in the universe, like this. That is here as Sun, S1, and this is S2, and this is called empty force, empty force. Clear? Empty. That is the empty force, and this is the Sun. Here is the point that is called P, perihelion distance, and here is the point. Here is the point P, aphelion. This is the point aphelion, and this is the point perihelion, and it is the distance like this. The distance between the perihelion point and Sun is 9142638 miles. It is at 4th January. It is at 4th January. On the 4th January, on 4th Jan 2020, IST 22 at the rate of Jamshedpur. A distance is here. Now just one day passed. Today is 5th July, and just one day passed 4th July. That is the 4th July. On 4th July just passed. Today is 5th July. Today is 5th July, last passed, and at that time the perihelion distance, aphelion distance is 945. This is miles. This is the miles. When it is converted into the kilometer, meter, that is the billion meter, that is the million kilometer. So it is converted this one, 945298041. What is 1 mile equal to 1.609 kilometer, and this kilometer is 1.609 into 10 to the power 3 meter, that is 109 meter. So here is equal and this is equal. So 1 equalate this one. So this is 1096 meter. So it is how much? And it will be 15. How much it will be? This is 94526 not. That is delete. 2980. 9452980 into 1609, that is 1.52098 into 10 to the power 11 meter. So okay, so it is, that is this one. This is called, that is 1.521. This is approximate equal to 1, and this is 10 to the power 11 meter. This is converted into meter. Now it is just same thing. It is 9142638 into 1609 meter, and it will be 1.4709. How much it is? Same things. It is 1 on 9 1 4 2 6 3 8 4 into 1609. That is like this one. This is 1. This is 1 0 5 0 5 1 9 into 10 to the power 11 meter. So here is like this. This is 1.471 into 10 to the power 11 meter. This is the distance. This distance is 1.471 into 10 to the power 1 meter, and it is converted like a million, billion. When it is shifted, this one 147.1 into 10 to the power 9 meter, and this is 9 meter called the billion meter. 147.1 billion meter, and converted into kilometer. So 110 to the power 3 meter is called kilometer. So billion kilometer is 9, this one. So 147.1 into 10 to the power 6 into 10 to the power 3 meter. This is called kilometer. So it is 147.1 into 10 to the power 6 kilometer. So here is also million kilometer. So it is can say that 10 to the power 6 is called the million kilometer from perihelion point to the center of the sun. Here is, so 147.1 million kilometer. Here is million kilometer, and here is the distance like this. Here is the distance like this. This and this distance, and this distance is called million kilometer. This is 1.521 into 10 to the power 6, 10 to the power 6 into 10 to the power 3 meter, and this is shifted to this one. This point is shifted to this one. So we write here 10 to the power 11 is right here. So 2 is here. 2 shifted is 10 to the power minus 2. So here is point. This one is called. This is when point is shifted to 5 to 0.1 into 10 to the power minus 2. Okay, and this is the 11, 10 to the power 11 meter. So here 152.1 into 10 to the power 9 meter, and this is 9. It's called 152.1 into 10 to the power 6 into 10 to the power 3 meter. This is called kilometer. When it is converted to kilometer, that is 152 million kilometer, and when it is 10 to the power 9 meter, then it is called billion kilometer. This is called billion, and this is called million. So here is converted. We know that the earth is moving on the elliptical path around the sun. While it is moving at a very high speed, its speed is 30 km per second, and it's related to the time period. 1 year, 365 days and 4 hours extra. So there is the 365 days is the total time to take in to reach complete one cycle or complete one rotation by the earth. And it is the time period, how much time taken to complete the one rotation of the earth. That is 3.14 into 10 to the power plus 7 second. And this is the second is million second. This is shift toward 1.4 into 10 to the power minus 1, 10 to the power plus 7 second. That is 1.4 10 to the power 6 second, and this is called 3.14 million second. 31.4 million second. That is the time period. This is the time period. So here is time period is there. So now it is we are proving this one, and actually is there. There's the centrifugal force is also here. So centrifugal force is how much? Like this one. Here is centripetal force. Like this force is, earth is here, this is called earth, and here is sun. Whenever the earth and sun is present in the universe, there will be the universal gravitational force. like this, and according to Kepler's law, the centripetal force like this, that is Fg, F into m1 m2 upon r square, and this is called the centripetal force of G according to Kepler's. This is the average distance, that is called the distance. This one and this one. What is the average distance between the sun and earth? What is the distance? So now we put out the value of this one. What is the average distance? Like this. We know the distance of perihelion and aphelion. This is the distance of aphelion, and this is the distance of this is the aphelion distance. This is the farthest distance from the sun, and this is the perihelion distance. This is the shortest distance from the sun. So the 2 point is that is the minimum and maximum point. There is a maximum point is there, that is called the aphelion point, and the minimum point is nearer the sun is called the perihelion point. The total is sum of this maximum and minimum and divided by 2, that is called the average. So now we find out the average distance of the rotation, average distance of the sun. So here is average distance like this. Here is sun. Here is sun. Here is sun is here. Sun. This is the point peri, and this is the point F. This is 151.21 into 10 to the power 11 meter, and this is the point. This is the point. This is the point. This is the distance like this, and like this. This distance is how much? 1.471 into 10 to the power 11 meter. So add this one and divided by 2. This is the average distance. This is the average distance like this. This is the average distance, like average, R average. Okay, this is average. R average is called the perihelion distance. This is perihelion, point S, sun, between this and this. Okay, this and this, and plus this is P, F, and S. This is S. Okay, this is called sun. This is called sun. This is called sun. As this, as, and this is divided by 2, and this is how much? 1.471 into 10 to the power 11, plus this is called 1.52 into 10 to the power 11 meter. This is meter just, and this is 2, and this is find out plus this one, that is that is called 1. This is called 1. 1, 2, 2, 7, 9, and 4, 5, 9.112.2, and divided by 2, and this is 10 to the power 11, that is 11 meter, on this 1.496 into 10 to the power 11 meter. This is the average distance. This is the average distance between the sun and earth. This is just like approximate equal to how much? 1.500 into 10 to the power 11 meter. This is the 11 meter. So we prove this one. This is the 11 meter, 1.5 or billion kilometer. That is how much? That is 152.0. That is this is when point shifted this one, and this is called one approximate this one, and the point is shifted like 0.2. Okay, this point, when the point is shifted like this, equal to 150.0 into 10 to the power minus 2 into 10 to the power 11 meter, and this is called 150 into 10 to the power 9 meter. That is called 150 billion meter. And now it is also called 150 into 10 to the power 6 into 1 10 to the power 3 meter, and the meter is called the converted into kilometer. One, it is converted into kilometer 10 to the power 3, and it is we called or known as million kilometer. That is 150 million kilometer. How it is million kilometer? We know that the speed of the light, 3 into 10 to the power 8 meter per second, is the fastest distance in the vacuum. What is the distance? What is the time taken to reach from the sun to earth while the fusion reaction takes place and the radiation takes there inside the sun, and the heat rate is very high. So radiation reaches toward this earth atmosphere, and it is time taken is 8 minutes 20 seconds. The total time in second, that is 500 seconds. So we calculate the distance from this and this. So here is, suppose that, look here, this is the distance. Here is sun, and this is the radiation, this is the earth. The distance, how much x, we don't know, but we know that the speed of light c equal to 3 into 10 to the power 8 meter per second. What is the time taken? The time taken 8 minute plus 20 second. How much? 8 into 60 minute plus 20 second, that is 4800, that is second. Okay, that is second plus 20 second, that is 20, that is 500 second, that is called 500. This and this 480 plus 20 second, that is called 500 second. 500 second, time taken 500 second, and this is called velocity of light. We know that the distance, the average distance, average distance between sun and earth is like this. That is called velocity. Average distance is velocity into t, that is called c into t, that is c means here is c, approximately equal to c. Velocity of light, that is called 3 into 10 to the power 8 meter per second. We don't write the unit of any physical quantities right here, that is 500 second. So it is multiply 500, this one 10 to the power 8 meter. We shifted this one like this, shifted this one, 2 digit is shifted like this. What is 2 digit point is here, that is the 50 point. This is 150 into 10 to the power 1 into 10 to the power 8 meter. So here is how much distance, like 150 into 10 to the power, this one 9 meter. So this one and this one and this one, this is the same things. Okay, this is the same thing. This is the average distance, perihelion distance, and aphelion, average and aphelion distance, and this is the direct distance, just like this one. Okay, this like this one. So we are taking the average distance while proving the numerical value of capital G. While proving the numerical value of capital G, someone asked me what is the unit of capital G, how it is equal to the centrifugal force equals like this one. Just our question is here. Our question is, someone asked me, okay, so I'm clearing your doubts. So yes, G equal to Newton meter square per kg square. This is equation 1 for the universal gravitational law. According to universal gravitational law, it is comes like this. This one, capital G is here, capital G is here, capital G is here. So this and this Newton, this is called capital G equal to force G into meter square. This is R square, and this is M1 M2, that is Newton, this is Newton, and this is meter square, and this meter square, mass square, this is a kg square. So this one is universal. So here is this one. Now while it is in according to Kepler's law, and in that case Kepler's law, centrifugal force and centrifugal force is there. What is centrifugal force? Centrifugal is force related to the orbit radius of orbit, that is called centrifugal force. So here is centrifugal force, mass into v square by r. Here is the acceleration, angular acceleration, while the body is like this, and this is the radius, and the velocity is linear velocity, and this the mass is there, and this is the velocity, and this is centrifugal force, and the Fc is equal to mass into acceleration. Centrifugal acceleration is related to the mass. This mass is rotated around the circular path or elliptical orbit or fixed orbit. Whenever the body is moving in a fixed orbit, the time there is the centrifugal force toward the center. So here is the centrifugal force is here, so it is mass into v square by r. So here is there mass square r, and it is the m1, and in the Kepler's law, in Kepler's law, in this case here is also body, earth is moving around the sun. So here is the earth, and here the sun and earth is present in the universe, in our galaxy family. So earth is moving around the sun, all 8 planets revolving around the sun in the fixed orbit. Earth is also fixed orbit, and its orbit distance, average distance is how much? Thus, this is the average distance like this, and this is called 150 million kilometer, 150 million kilometer, 150 billion meter. So this is called 1 billion meter, and this is a kilometer. This is a kilometer, million kilometer. So here is 150 million kilometer at a distance. So here is universal gravitational force is there. So here is universal gravitational force is there. So that is m1 m2 by r square. This is the average, this is average, this is average s square. This and this will be cancelled, this one, this m1 m2, and m1 and m1 are also cancelled. So here is cancel, r apparently is there, v square is 1, cross by multiplication, then we get the g equal to v square into r ap, and this is mass of, and this is the mass m2 is greater than m1, and this is considered m1 m2, and mass, this is the mass of the sun, our center of the our solar system. So here the center of the solar system, that is center of the solar system mass, and it is mass, this one, and this is while putting the value of SI unit, while it is putting the SI unit, just different this one, how it is equal, just it is our question. Someone asked me how it is equal to the this one. So this one is this and this one. So meter s square, and this is second s square, okay, and this is meter, and this is mass, this is kg, that is meter into meter square plus meter, that is meter cube, and this is the second s square, this is 1 upon kg. This is the how it is equal to this one, and this is the Kepler's, according to Kepler's g equal to this value, and after getting this one, and we know that this is the value is 6.67 or approximately equal to 10 to the power minus 11 meter is this is meter cube second s square into 1 upon kg. This is according to Kepler's. So here is 6.70 into 10 to the power minus 11 meter cube second s square and 1 kg s square. Now it is proved. The question someone asked me, what is the distance, what is the unit of capital G according to Kepler's? This is equal to this one. How it is equal to each other? So that is the our doubts. So it is clearing totally simply way. So this one is this one. So capital G according to Kepler's, and this is how much? Meter cube second s square and 1 upon kg equation to how it is. This and this same things, there is 6.67 into 10 to the power 11 Newton meter per square, and here the unit is this one, the numerical value is this one. This, while proving this one last class, at that time, according to Kepler's law, this is the equal to this one. We have to prove this one. Newton meter square per kg square is equal to meter cube second square into 1 upon kg. This is equal to each other. So here is perihelion distance just like this one. Okay. Always you remember that, because our last class was about the topic of universal gravitational constant. While derive the numerical value of universal gravitational constant, at that time we use the application, we use the formula of Kepler's law, because we know that the Kepler's law is says or apply in the universe. Whenever the body is in the universe, there with the Kepler's law would be implemented. So here is Kepler's law would apply here. So whenever the Kepler's law apply, at that times this and this will be equal. This is our how mq s square into 1 upon kg equal to Newton meter square per kg square. How it is called? It is our question. Someone asked me. So that is just proving this one. Okay. Actually, little bit ago, I am proving this one. Someone call me, and when received the call, at that times whatever I taught few minutes ago, all delete. So once again I am making a video about this gap which is missed. Okay, whatever missed the teaching of or proving of or answering of someone asked me, so it is proven. Okay, so our question is here. So always you know that here is this is sun, this is point, and is point PF 52.166 kilometer or okay kilometer. So 152 million kilometer. Okay, that is called the billion kilometer. Often also you can say that this one. Okay, so you can say this one 1.521 into 10 to the power 9 meter, and point is shifted like this one. So 1.52 in 1 10 to the power 2. 2 digit is here, to plus 2 and 10 to the power 9 meter. So it is 1.521 into 10 to the power 11 meter. So this is the perihelion distance, and here is peri, that is 1471 point into 10 to the power 6 kilometer. This is called million kilometer, and 147.1 into 10 to the power 9 plus 3, that is called meter, because kilometer is converted into meter. So 1 kilometer equal to 10 to the power 3 meter. Okay, so here is taken here 147.1 into 10 to the power 9 meter. My point is shifted left side, then in the exponential plus. Okay, 1.47 into 1 10 to the power plus 2 into 10 to the power 9 meter. So 1.471 into 10 to the power 9 plus 2 meter, that is 1.471 into 10 to the power 11 meter. So this is the perihelion distance, and this is the aphelion distance. And this is the average. Everywhere, every distance is 149.6 into 10 to the power 6 meter, and it is approximately equal to 150 into 10 to the power 6 kilometer. Okay, sorry, kilometer. So 150 into 10 to the power 6 plus 3 meter. So 150 into 10 to the power 9 meter. When it is point is like this one, 1.50 into 10 to the power 2 into 10 to the power 9 meter, that is 1.5 to the power 11 meter. This is the average distance. We use the average distance, then the centripetal force and universal gravitational force is equal to each other. We using this one or approximate value. This is the average distance of perihelion and aphelion distance. We use this one distance, this one. Okay, mass of earth is 1.989 into 10 to the mass of sun is, that is 30 kg. Okay, and here earth is moving like this, earth is moving here, earth is moving like earth. Okay, mass of earth is 5.97 into 10 to the power 24 kg. Here is this one mass of earth, and this is the mass of sun, and this is the aphelion distance, average distance between the elliptical path, average of elliptical path, average distance between sun and sun and earth in the elliptical path, elliptical path of earth. Earth is moving around the sun. Okay, how much time period is there? 31.4 billion second with the time period, one revolution. So here is, so it is a part of which is actually cut out from after coming call. So here is, and next part is adding. Okay, so thank you. Okay, immediately resume this one. Someone call emergency call. So now resume freshly. Here is universal gravitational force. Okay, universal gravitational force is how much? At it is G, m1, m2, and r square. This is the average. This is called average. What is average? Average value, r average value is how much? 149.6. 149.6 into 10 to the power 9 meter, and EV it is 1.496 into 10 to the power 11 meter. Both are the same things. And mass m1 is considered mass of the earth, that is 5.97 into 10 to the power 24 kg. m2 is considered mass of the sun, the center of our solar system, not galaxy. m2 1.989 10 to the power 30 kg. This is the average distance, that is average distance. RAV is, this is average distance. This is the average distance, and this is m1, m2, and here is capital G. Here is capital G. We are proving f G equal to fc. Why it is equal? After equaling this one, then we get the equation. Then we get that is v square into r by m, that is capital G, and this is the equation from the Kepler's law while proving universal gravitational constant. Okay, so here is how it is proved. This one, like this one, it's the very important things to know. So here is m1 and m2. This is capital 6.67 into 10 to the power minus 11 Newton meter square per kg square. While putting the value of this one, 6.67 10 to the power minus 11, mass of earth 5.97 into 10 to the power 20, okay, 24. Mass of earth and mass of sun is here, mass of sun is here, that is here we write phrase this one, okay. 6.67 10 to the power minus 11 to 5.97 into 10 to the power 24. Here the mass of sun 1.989 into 10 to the power 30 kg. This is the numerator part, and this denominator part is how much? This one, 1.496 into 10 to the power 11 meter. So here is meter. Calculate this one. We use the calculator. Here is the calculator, this one. So we calculate this and this one, and this one. Here is 6.67 into 5.97 into 1.989. This is how much? This is 79.20178. So we are taking just this one, okay, and this is in 10 to the power minus 11 plus, this is plus 24 and 30, that is 54, that is plus 54, and this is the s square of this one. So squaring this one, 1.496 into 1.496, how much? This is 2.238 into 10 to the power, this is 11, power of 11, 10 to the power 11, that is 2, 10, 11 into 10 to the power 11, that is 10 to the power 11 plus 11, that is 10 to the power 22, okay. So here is, don't multiply this one, 1 into 1, 1 into 1, 1 to 1. Don't multiply this one because the exponential is 8, well it is a linear or product. So here is 22, and here we consider this one 79.20 only taken, okay, 20 only taken there, and this is 2.2, this is called 40, and 10 to the power minusing this, minus, have a minus here, that is 3, and this is 4, and upward direction is, it goes upward direction as a 22. So here is approximately 79.20 approximately to 80, that is equal to 80, and this one is actually this one. So that is 80, and this is 2.24 into 10 to the power minus the 121, and this is your numerical value. So we divided by 2.42 to 80. So divided this one, 80 is divided by 2.24, that is how much? That is 357 in point 0.2 into 10 to the power 21. This shifting, that's one left side, the point is shifted left side, then 3.57 into 10 to the power plus 1, and this is 10 to the power 21. So sum this one and most simplified this one, this is 3.57 into 10 to the power 22 Newton. This is Newton, this is Newton, this is Newton, this is Newton. So this is Newton, force is Newton, this is force is Newton. So it is approximate value is how much? 3.60. This is how much? 57 approximate equal to 60. So here is into 10 to the power 22 Newton. Here is 1.9 here is not this one, 3.6 at the average distance. The universal gravitational force is like this one. This is a huge quantization, huge quantum. So here is quantitative term, this one, 3.60 into 10 to the power 22 Newton force is acting at the average distance. The force acting, universal force acting between sun and earth, this force is acting between sun and earth. While the earth is moving around the sun, then there will be a centrifugal force acting. So let's find the centrifugal forces, how the numerical value of centrifugal force. If there is equal each other, then we find this one, okay, this equation, and it is the equation of the Kepler's law. So let's find this one. Okay, student, I'm just going to make you understand detail. Don't confusions again and again. So here is, so here is numerical value of Fg. This is the Fg is how much? Fg is 3.60 into 10 to the power 22 Newton. So F, there is, what is F? That is Fc equal to mv square by r. Okay, here is earth is moving like this one, this is earth is moving, b equal to 3 into 10 to the power 4 meter per second. Okay, its comes is 67,000 miles per hour, and while it converts 67,000 into 1609 meter. Okay, when you converted this one, this is miles per hour, this is miles hour second. So here is 3600. When it is converted this one, and it is how much? Let's convert this one. Okay, 67,000 into 1609, 107,803. Okay, 000.00, and this is 3600 into 10. Okay, this is meter per second. We are converting meter per second. This is not exact value. This is the exact value, 29.94 kilometer per second, and this is like this in meter, converted into meter. So this is approximately equal to 30, and this is kilometer 3 meter per second. So it is 3 into 10 to the power 4 meter per second. So here is like this. When you convert in this one, and it will be 29. So here is converted this one, that is meter per second. So is divided by 3600. Okay, that is 29 9 okay, 945.07778. This is meter per second. This is when I shifted this one. This is 1 2 3 4 2.994527778 meter per second. This is approximate. This is into when the point which shifted 1 2 3 4 into 10 to the power plus 4. So here is 2. Only 4 digit taken here. That is only 2 digit is taken. So is 10 to the power 4 meter per second. That is 4. That is 4 meter per second, and it is approximately equal to 3 into 10 to the power 4 meter per second. Okay. So here is how much distance? Here is distance, velocity is like this, and average distance, we know that average distance is how much? 1.496 into 10 to the power 11 meter. This is the 11 meter. This is the 11 meter. And mass, we know that Earth is moving. So here is Earth is moving around the sun. This is, here is sun. Those mass is how much? 5.97 into 10 to the power 24 kg. This is the mass of the Earth, m. So here we put the value and calculate this one. So how it is come? We are taking only exact value. This we are taking only exact value. We are taking like this value. Okay, we are taking this value and this value, exactly this value. So how it is convert this one? So here is putting the value, this one. Mass of the Earth, that is 5.97 into 10 to the power 24 kg. What is the velocity? Velocity is, what is the velocity? Approximate 3 or equal to 2.99. Okay, 2.99 into 10 to the power 4. That is a square. That is a square. This is perihelion distance. That is perihelion distance. Average. This is called AV. 1.496 into 10 to the power 11. Okay, so calculate this one, and a square of that. This is a square, 5.97 24 2.2. How it is? 2.99 into 2.99. That is 8.94010. Okay, and this is 2 times. This is 2 times. Here is also 2 times 10 to the power 4 plus 4, 8. Okay, this is 4, and this is 1.496 into 10 to the power 11. Now multiply this one. Multiply 5.97. That is, okay, how it is? 8.9 2.2. Okay, 2.99 into 2.99. That is, okay, and this is multiply 5.97. That is 5 point, how it is? 37. 3.37. 7337. So it is 10 to the power, multiply this and this, and this and this, that will be 32, and here is 1.496 10 to the power 11, and now it is divided by, now it is divided by 40, 53.40 is divided by 1.496. Okay, and this one is, this is called this is 53.37 approximate equal to this is approximate equal to 53.40. we write here 53.40, and this is 1.496 into 10 to the power, goes upward direction, and it is how much? 35.695 into 10 to the power 11. Oh, that is 21. Okay, that is 21. Now this one, here is exact value is coming here. Had the exact value is coming here. So it is a very rare things while calculating this one, is the exact value is coming. So it is a very rare. So here is, that is approximately 695 approximate 700. So we are right here. We are right, this one is right point this one 35.700 into 10 to the power 21. When the point is shifted like this one, 3.5700 into 10 to the power plus 1, because point is shifted left side and its exponential is plus. If shifted 1 point, then that exponential term is 10 to the power plus 1. So here 10 to the power plus 1, shifted only 1 digit. Look this here, student, 10 to the power 22 Newton. Here is, look this here, This is the equal. This centrifugal force is equal to the universal gravitational force. This is the same things equal. What it is equal? Then we find this one. Here is equal. This is approximate equal to how much? This is real things. This is 3.60 into 10 to the power 22 Newton. So how can you see this one, students? This is the equal each other, equal to each other. So we here this one in this equal. So here is 3.60 into 10 to the power 22 Newton. So this and this equal. The centripetal force is equal to each other, and this one. After getting this one, this and this is the value is this one. So here is this one centripetal force after centrifugal equating this one. So here is equating this one. So here is both are the same things, like this one. 3.57 into 10 to the power 22 Newton equal to 3.57 into 10 to the power 22 Newton. This is the centripetal force of the earth. This is the universal force between earth and sun. This is called universal. This is both are equal. This is the centripetal force, and this is called G m1 m2 by r square. This is the average distance between sun and earth in the universe. So here is this is the m1 v square by r average, and this one is cancellation this one. This and this will be 1 r is cancelled. This one capital G r m1 and m1 cancel, m2 and r average, which is v square by r. This is only v square cross by multiplication. This one, that is capital G equal to v square into v square equal to v equal to r average. This is mass. This one and this one, unit of this one, how it is unit this one. Put the value of unit. Put the value of this one. Here is mass. This is v square. This is meter square by second square. This is the average distance r average. This is meter. This is the mass. This is the kg. This is a mass, the kg. Now here is proof this one. M square. This is kg and this is meter. Here is meter cube upon kg and second square. Here is second square. This is the second square. Here is second square is not written here. Actually here is second square, and this is the k. This is k. Meter square and meter, that is q, and second square is here. This is the second square is here, and this is the k, kg. Now how it is this and this one? It is very simple. It is equal to each other. It can be equal to each other. So we are playing blinding. I blind my eyes and I equalize this one. Okay, this one is cloth is red cloth like this, a piece of red cloth like a rectangle. We are like this one fold, and this is two fold, one fold, two fold, and three fold. If three fold, there is the four layer. There is four layer of this one. Okay. Now a spectacle is removed, and now putting the value like this one, like this one. Okay. What is where is my, here is, okay, this one is like I'm proving this one, Newton meter square per kg square. How it is equal to meter cube upon second square and kg. So here is remove out my this one. I'm not visible to in front what is there. My here is it is the experience when it touch this one, my sensitive is understand that it is the whiteboard and this is marker. So here is rubbing this one, rubbing this one. So in the universal gravitational force, it is the Newton. This is the Newton. Universal gravitational force is how much? That is the universal gravitational force is how much? That is universal gravity. This is Newton meter square per kg square. Okay. Now Newton meter. Okay, that is meter. Okay, you know that 1 Newton is how much? 1 Newton is how much? 1 Newton is how much? Force. 1 Newton means force, that is force. What is force? Force is m into a. This is m into a. What is unit value of mass? That is SI unit of mass, that is kg, and the SI unit of acceleration, that is meter per second square. You means that 1 Newton is equal to kg meter per second square. Okay. So here is 1 Newton meter square per kg square. So here is 1 Newton. How can we written this one? In place of 1 Newton, that is in place of 1 Newton is written kg, okay, meter per second square. Okay, and then that is a meter square, okay, and then that is kg square. Upper is 1 kg square and here is kg square. 1 kg is cancel this one, and then we get one, that is meter and meter square and second square, and that is kg. Upper side like a meter square and meter, it will be how much? That is meter cube and second square, and this is 1/1 upon kg. This is the unit. So how can you understand this one? This is this one and this one. Look this one. How can you understand this one? So here is both are the equal. This and this will be equal. Here is simplify this one. So here's kg and kg square is cancel this one, and this is equal. So dear student, your answer is right here in my backside. Thank you for watching this video. Keep watching and subscribe my channel. Have a nice day.